Share your screen, Chelsea.
It is shared.
Okay, can you hear me now?
Yeah.
Okay, so after Christmas, you guys are always brain dead. So I'm going to do some. Okay, so how do you differentiate tan of?
Why is it not working? Hold on.
How do you differentiate tan of x?
Why does my thing keep freezing?
Is it normal or is it?
I think my pen is dead or something.
Oh, probably out of battery.
Yeah, it's not working.
Do you have a another pen?
Yeah. Let me see. Oh, I have this one. It's not as good, but I'll use it. Okay.
Test. It is only good.
It's just very. It's very uncomfortable because it's not my original pen, but it's fine.
Okay. So how do you differentiate tan of x? So charge the other pen, okay, Sophie? Not now. Put it on charge when the lesson's over. Anyway, how do you differentiate tan of x? Can you remember?
Yes.
What?
Tan -1.
Oh no, it's not like you can't think of it as being like this. You were thinking of the power coming down, the x stays the same, and you were thinking about that, were you? Were you? Chelsea?
No. I was just thinking of inversing.
Oh no. What you do is you have to think of tan as being sine x over what? Can you remember? What's tan x the same as?
Sine x over cos x.
Yeah. This will always be true. So this block here is the block of tan. So if you want to differentiate this, how do you do it? If you want to differentiate one thing divided by another thing, what do you do?
Sine x minus cos x.
Sine x minus no. You got to use So what happens when you want to?
ln.
No.
Oh no. U prime v prime thing.
Yeah. So what do you do? Can you remember?
I can't remember
this?
the formula.
Okay. So if you can't, then you have to Google it. But it's a quotient rule. Okay. The quotient rule says that if you scroll to the right or zoom out slightly, the quotient rule says that you square the denominator, and then the v stays the same, and then you differentiate the top, and then you take away, and then you differentiate the bottom, and then you leave the u alone. Yeah. But Chelsea, no one writes cos like this, even though it is what it is. But what's a neater way of writing it?
I
A neater way. This is a neater way.
Oh, that way. Okay.
They're both the same.
Cos x.
Yeah. And then what? The v stays the same.
Yes, so v stays the same, so it's cos x.
Yeah. And then you differentiate the u.
U prime. Would that just be sine x?
No, the u is this. You got to differentiate that.
What is that differentiate? I don't know. I don't remember.
When you differentiate sine, do you know what it becomes? When you differentiate cos, do you know what it becomes?
No, I don't remember.
When you differentiate sine, it becomes cos of x.
Oh, and that becomes negative sine x.
Yeah, negative sine x. So yeah. So can you tidy this up? This is like one block multiplying with another.
Squared x?
Yeah. Yeah.
Minus v prime.
And then you got your minus. Oh, you've got your minus already. And then it's v prime. So differentiate the denominator. Yeah. And then leave the u alone.
square x.
Yeah. And do you recognize, can you simplify it? Oh, what do I put in here, Chelsea? What do I put in the box?
dy by dx.
Yeah. Okay, now what? There's some, you can simplify this fraction. How do you do it? How do you simplify that fraction, Chelsea? Do you recognize anything?
That you can delete the cos squared x.
Well, what, like
Cancel
this?
it out. Yeah.
Like that? No, that's not
No.
true. Everyone thinks that. What's a plus? You see, if you have like a b plus ac divided by a, how would you simplify this, Chelsea?
Delete the a's.
How? What does that mean?
No. I would put a like that and then put b plus c.
Yeah, you would factor out the and press on blue, Chelsea. Press on blue 3 times. So you would factorize out the a because a is in common. Can you see that? And then you would visualize it like this, Chelsea. A over a times b plus c, like this. Because if I were to give you a bubble and ask you to multiply a fraction, it gets multiplied to the top, giving you this, right?
Okay.
This thing
Oh
here.
yes, I see.
Right, but then if you look at this, Chelsea, if I were to give you this, let's say a, so this is like a here, plus something else divided by a. How would you simplify this? Chelsea, the thing is here, you can't simplify this because you can't simply do this. Do you know why?
Because why? Because it's not
Well,
multiplied to the top. It's not multiplied to the b.
you had to factor out the a, but here you can't factor out the a. You see that?
Oh, okay.
So you've got no choice but to leave it as it is. You see, if you have something like this, let's say b plus c over a, then these two, they will cancel each other out. But here, these two won't cancel each other out because you've got this plus here. Because if you look at the bottom fraction, Chelsea, if you look at the bottom fraction, it's like this. You can rewrite this as a over a times b plus c, right? How can you do so this thing here is like the number 1. How would you do this? How would you use a technique to simplify the top? You can't. So you've got no choice but to leave it as it is. You can't simply do this, Chelsea. You can't simply do this. You can't simply cancel out the cos's. Can you see that? Yay or nay?
Yay.
Right. Really, when you say, "Oh, I'm going to cancel out," the reason why you can cancel out is because you can rewrite it like this, as like the number 1 times the bubble, because this here is the number 1. 1 times anything is the same. Anyway, Chelsea.
Okay.
The thing is that these two, they can cancel each other out, but up here they can't. Okay.
Okay.
All right. So going back to here, you can't simply do this. You can't simply do that. So what can you do? What can you do?
Let me think. Can you? No. Let me think.
Do you recognize this?
No.
All right. Hang on. So you're supposed to know this by heart. If you have a circle, a unit circle of radius 1, so that means the hypotenuse is 1. What's this green line here? So let's say you have an angle. What's that green line?
Pardon?
What's the length of the green line?
Oh, sine squared x.
Sine squared x. X is not in there. You're just working with the number 1.
Sine 1
And
squared.
you're
Sine squared 1. Sine.
what?
Sine. Sine. Sine.
Sine.
Sine
Like,
theta.
okay, so what's the across? What's this red line?
Cos theta.
Okay. Do you tan theta equals what, Chelsea? Tan
Sine
theta.
theta over cos theta.
Yeah, that's because of this, right? Can you see that?
Okay.
All right.
Okay.
Use Pythagoras. If I were to let's say I didn't know this was a length of 1, how would you go about working out the red length, Chelsea? What's the red length? Remember Pythagoras?
Oh, yeah.
Yeah. So go on, use Pythagoras to come up with a formula. So 1 squared equals what? Yeah. Yeah. What about it? Equals what? Equals c squared. C's not even in there, Chelsea.
Oh, 1 squared.
Yeah.
1.
Yeah, 1. But Chelsea, no one writes sine squared like this, because if you
I'm
were to do
changing
that,
it.
oh, then why bother writing in the first place? Why not just jump to this?
Because it's the first step by step.
No. This is not even a valid step, because you're supposed. If you were to do this, you would have to write it like this: brackets squared. Because if you were to write it like what you did, people would think you're squaring the angle first, and once you've squared the angle, then you sine it. So this is not right. Just jump to this straight away, Chelsea, next time.
Okay.
All right. So now,
Okay.
all right. So going back to here, Chelsea, do you recognize anything about this fraction?
No. Oh,
No.
it's the Pythagorean theorem.
Well, anyway, how would you simplify this? How would you simplify that fraction? How would
Let
you
me think.
simplify that fraction?
Let me think. No, I
You
don't
can.
know.
All right.
10?
See that green box?
Oh, can you separate both of them?
No. Wait. See that green box?
Yes.
Green box is the same as this. So what? And this is the same as the number 1. So why not put the number 1 into that box?
Oh,
No, the number 1.
so it's
Oh, it's
1
not.
over cos squared x.
Yeah, 1 over cos squared x. So when you differentiate tan, it becomes 1 over.
Oh, oh, we're
Over.
differentiating tan x.
Yeah,
That's on my
because
whiteboard. I didn't realize.
yeah, well, tan x is this thing here. So when you
Mm-hmm.
differentiate it, it becomes this. Okay.
Mm-hmm.
If you're good, then you can just memorize it's 1 over cos squared
Yes,
x.
it's on my board. I just forgot that I was looking for tan of x.
Yeah, but most people they can't remember it, so they have to turn it into this, and then use the quotient rule to slowly differentiate it to give you this. It takes
Yeah.
ages. You can remember it straight
Uh-huh.
away. Okay? So,
Mm-hmm.
what's the quotient rule?
Quotient rule is
For the quotient, you remember?
v squared
Yeah.
u prime.
Oh,
No, v
what?
v
Yeah,
prime.
get in the habit of just dragging this v. No, get in the habit of dragging this v up, and v stays the same. Chelsea.
Oh, v u
Oh,
prime
yeah,
minus v prime u.
yeah, and that's your quotient rule. Okay, and what about the product rule? What happens if you try and differentiate one thing times another thing? So differentiate
Oh,
this.
you have to times the derivative.
I don't know, but what goes in here? Can you put it down?
Um. Uh.
So it's like me. It's like me saying this, Chelsea. I want you to differentiate this one thing times another thing. So you've got two blocks, two functions, and they're being multiplied together.
So you have to keep the first
So this
one,
is what
change the
you do.
second, change the second, keep the first.
Yeah, we'll put it down in writing. What's the
keep the first one the same, change the second, plus keep the change the first.
yeah, whichever way. Oh no, you
Oh
don't
shoot! I'm
differentiate.
oops.
Yeah, there are lots of ways of doing it, Chelsea. You could say, oh, I'm going to differentiate the first, and then I'm going to leave the second alone, and then plus, and then I leave the first alone, and then differentiate the second. They're both the same. Okay, Chelsea. So how would you differentiate y equals x sine x? So you're saying leave the first alone, differentiate the second, plus.
I forget what x differentiated is.
How do you differentiate x? Y equals x. Well, y equals x. If you look at the graph, y equals x, it's like a diagonal line at 45 degrees. So when it's 1, it's 1.
Oh, it's just one.
When it's 2, yeah. So this has a gradient of 1. So when you differentiate y equals x, it becomes, yeah, y equals 2x. When you differentiate it, it's just 2.
Okay.
Anyway, so you differentiate the first and leave the second alone. Yeah. And what goes in here, Chelsea? You can't leave it blank. If you leave it blank, people will assume it's just y.
Dy by dx.
Yeah, dy by dx. Okay, next one here, Chelsea. How do you differentiate this? Y equals sine squared of x. Remember, we've done all these before. You should know all these.
Yes, but it's been ages.
Okay, coming on.
I think.
Give up? Yeah, you give up. Okay, so imagine
No.
what?
No. Okay, fine.
Give up, right?
Yeah.
So imagine this as being like a bubble squared, because that's what it is, sine x squared, right?
Okay.
Chelsea?
Oh, and you bring it to the top. You bring it to the front. It would be 1/2.
Yeah. So now you can differentiate it. So this is you using the chain rule. So dy by dx equals what? The 2 comes down, the bubble stays the same, the power gets minus by 1, and then you times the derivative of the bubble itself. Yay or nay?
Repeat. So wait. So you bring that to the top. Now minus 2 from.
Put it down in writing.
Okay, so you basically bring it to
you drag the 2 down, the bubble stays intact,
minus
the
1
power gets minus by 1.
times
Yeah, times the derivative of the bubble itself.
positive.
Yeah.
Yes, that's what I just did.
What? And then tidy this up?
Tidy.
Yeah, tidy up.
How do I tidy it?
Well, first, do you really need the brackets? Because when people look at this, they know it's one block times another block times another block. Do you really need the brackets, Chelsea?
Yes.
It's like saying, no, you don't. Because if you were to remove the brackets, when people look at this, then they'll automatically know it's one block times another block times another block. Why do you need more brackets? It's just like me.
Because it helps me.
What? How does it help you? It litters the whole thing. Look, that litters it. It's just so confusing. So why don't you do this as well? So why don't you do this as well? Why don't you do this as well? It looks ugly, right? It's easier.
Yeah, you're right.
It's easier just to leave it like this. So when people look at it, they know it's just simply one block times another block times another block. That's all it is. It looks neater. And when you have so many things, it clutters the whole thing, and it makes your math hard to read, and people get confused over it.
Okay, but people don't need to understand. I just need to be able to understand it.
Just leave it just leave it in a neat form, so it helps other people to read your work. All right, how do you differentiate this? Sine, no, actually, let's use cos. Cos to the power 7x. How do you differentiate this? Oh, scroll up a bit.
Cos 7.
Yeah. You don't like it?
I've never done 7.
32 then.
Stop. Go back to 7.
No, who cares? Just leave 32.
Go back to 7. Who cares? And go back to 7.
You're crying over nothing.
Go back
to
7.
Chelsea, you're crying over nothing. It's just like one bubble to the power of 32. Okay, how do you differentiate this?
Go back to 7.
Doesn't matter. All right, the bubble comes, the power comes down. Go back. Come on, just do it.
Okay.
So it's 32. The bubble stays intact. Yeah, but Chelsea, if you write it like that, people will think, oh, you're getting X, and then you're
now they think.
Now you use that, but that's amateurish, Chelsea, because people would just write it as X cos to the power of 31 X like that. It's much neater. Can you see that? This block here is the same as this block. Can you see it?
Mm-hmm.
Yeah, no. Can you see it, Chelsea?
Yeah.
So wait there. Let's start again here. So how do you differentiate that?
Let me think.
Chelsea?
What? 32.
Yeah, 32. Yeah. But don't
31.
don't put it there, man.
Oh, cos 31x.
Yeah. Okay, now what? You got to times with the derivative of the bubble itself.
Minus sine x.
And then you're done, right?
No. I think it's easy.
Brilliant. Okay.
Idiot.
So now, how do you tie? You can't call your uncle an idiot, Chelsea. Anyway, how do you tidy this up? Because you've got one block times another block times another block. You don't actually need the brackets there. But if you remove the brackets, people are going to think it's these two blocks take away this block. So how do you tidy this up? How do you tidy up, Chelsea? Because it's like me saying the number 32, let's just say cos x, that's one block, and then times minus 1 times sine of x, isn't it? So you can merge this 31 with, you can merge the 32 with the negative 1. Can you see that, Chelsea?
So it would be negative 32?
Yeah.
Okay.
Go on, put it down in writing. Yeah. So when people look at this, can you see you don't need the brackets and you don't need the negative being in the middle of nowhere. You can put it out in front. So people can just look at this and see, oh, it's one block times another block times. So it's basically 3 blocks with a negative 1 in front. Okay, Chelsea?
Okay.
All right, next one here. How do you differentiate this? Y equals 1 over sine of x. Give up?
No. Let me think, okay? Just let me think.
Summon the Almighty.
No, I got this, idiot. I've got it. Can I do this?
Does that? Yes, you're supposed to do that. And what goes in here, Chelsea?
Well, DIY? Why?
DIY. What does DIY mean?
Why?
Because I'm asking you to. What goes in there?
Why?
Because I'm asking you to. What goes in there?
The letter Y.
Okay, come on then. So differentiate it.
Okay. Then you push it on top.
Brilliant.
That would be -1 minus 1 would be -2. -1 minus 1. Yeah, -2. Times the derivative.
Yeah.
It's
Of the
cos x.
Yeah. But if you write it like this, Chelsea, people are going to think.
-2. There.
Yeah. Well, when it comes to sine, avoid doing that, Chelsea. I know when it comes to sine, try to get in the habit of doing this.
What the hell?
I know, Chelsea, it's kind of weird. You got this thing here. By using your notation, you would write it like this, right?
Okay.
But then this is inverse sine. You see, there's a lot of confusion when it comes to this notation. These two are not the same, Chelsea. Even though by using our notation, you see, when it's like sine to the power of sine x to the power of, let's say, 5, I would ask you to write as sine to the power of 5x because it's cleaner. Okay, Chelsea? Chelsea?
Okay. Mm-hmm.
But when it comes to -1, I'm not going to ask you to convert it to this because there's a lot of confusion because we use the same symbol to represent inverse sine. So these two are not the same. For the case of it being -1, don't bother converting it into this because it gets a bit confusing because it means inverse sine. So when you're in this case here, Chelsea, leave it as it is. Don't bother changing it. Do you understand what I'm saying?
Yeah.
Just leave it like this. It's just a special case of -1, or maybe -2.
So if it's negative,
well.
you do it like that.
Yeah. Otherwise, it gets confusing because in our case here, if you convert it to -1 like this, people are going to get confused because they're going to say, "Oh, this is inverse sine," but it's not. It's actually this thing here. I know there's a lot of confusion, Chelsea. When it's a negative, don't bother changing it. Leave it in its ugly state. Okay. Okay, Chelsea.
Okay.
So when it comes to this, Chelsea, write it like this: brackets, and then to the power of -2. It is ugly, but leave it as it is in this case. Okay, Chelsea.
Okay.
Right now, how do you tidy this up? Because at the moment,
you tidy it up.
You got another block times another block.
Yes. So I want to. Can I bring? No. Hold on. Let me think. Okay. Now.
Now what? Your eyes to zoom into this block here. We don't understand what it means to have a power of
yes.
Yeah. And don't forget, you still got your block of -1 out here. Yeah, that thing there gets multiplied multiply this to the top. Yeah, and that would be your final answer.
Yes, beautiful.
Okay, how do you differentiate this? Y equals sine x cos x.
Okay.
How do you differentiate it?
Let me think.
Give up?
No. I got this. You have to believe in me.
Bit
You
hard.
believe in me?
Not really.
It's multiplied to each other, right?
Yeah, they're being multiplied with each other. So what?
Okay, so
Is this block a variable or is it a constant?
it's yeah, it's a very constant.
No. If I were to do this, Chelsea, this thing here would be a constant. It's just a number. It doesn't change.
It's
It doesn't.
variable.
This thing here is a variable. This block is the whole block is a variable. You see, this thing here
I don't know how
contains.
to do it.
Well, this thing here is a variable. This thing here is a variable, right? Yay or nay, Chelsea?
Yay.
Chelsea?
Yay.
Well, anyway, this block here is a variable. This block here is a variable. So this is like a function that contains x, and this is like another function that contains x. So what do you do?
What do you mean? What do I do?
Well, how do you
I
differentiate it?
don't.
You use the product rule. Differentiate the first, leave the second alone.
The first. Leave
Yeah.
the second alone.
And then you
Leave
plus,
the second.
leave the first alone, differentiate the second.
Stop. You're messing with my head.
Final answer?
No, thank you. Yes. Sorry. Leave the second alone. Differentiate the second. Cos x. Oh shoot! I did that wrong. Minus Sine x.
You done?
Wouldn't that just cancel out?
No, you see, you're supposed to times. You're supposed to times the derivative with the second.
Yeah.
So that's why you need
Oh
brackets.
yeah.
Without the brackets,
I
people would think it's
forgot.
okay. So now what? That looks ugly. So how do we prettify it? Give up?
Wait, let me put my headphones in.
You put your what in?
My headphone in. Okay.
So now, so you just got two blocks being multiplied together. So what do you do? It's like me asking you this, Josie. Let's say, what's W times -1 times W? Merge these two together, it will give you minus W squared. Can you not see it, Chelsea?
Wait, what? I'm so confused.
Well, you got two blocks being multiplied together. That becomes minus sine squared, Chelsea. Chelsea.
Wait, I don't get it.
Okay, how would you simplify this? They're being multiplied together. Okay?
Combine the W's, so that would be negative W squared.
Yeah, because I would imagine the negative W as being -1 times a W, because that's what. And then you've got a block of W here, Chelsea. Merge these two together. Can you see that, Chelsea?
Wait, let me think. Why is it two W's in one?
Okay, this W here is this thing here, right?
Yeah. Oh. This one is
No.
this broken down to this.
Yeah.
Oh yes, then I get it. Very easy peasy.
and then you can just merge these two together.
Yes, very easy.
All right, so go and tidy this up.
Oops.
Yeah, and what goes in here? What goes in here?
Dy by dx.
Yeah, you have to put it in there. Otherwise, leaving it blank, people will assume it's the same as what was previously, which was the y. So you need to stick. Anyway, how do you differentiate this? Your favorite y
Oh,
equals.
jeez. No. Oh, yes, I like this.
Your Achilles heel. You always get stuck on this, right?
No, because I love doing this one.
Come on, then.
Yes, just give me a second to think.
You can't love it that much if you can't remember how to do it.
No, I do remember this. Because you taught me it.
A million times. What's that? Square root? Natural log looks like this.
Oh, shoot.
When I ask you to draw the natural log, in your mind, you could picture e to the power of x, right? And then the natural log is really a reflection along the diagonal line of e to the power of x. So it looks like that. Right, Chelsea?
Sure.
Yeah.
Sure.
Anyway, what are the coordinates here, Chelsea?
Hold on, I'm thinking. Oh, no, I'm trying to do this thing, not this.
Okay. Come on.
Okay. So, first thing I want to do is, well, you see.
Well, play for Christmas. That's what you want to do.
Let me think. Okay, so, first thing I want to do is
Play for
E
Christmas.
everything.
Yeah. Exponentiate both sides with base e.
E to power of y, e to power of ln x.
Yeah. But remember, we don't. Whenever these two are the same, Chelsea, remember they cancel each other out.
Yes, so it's just
So
x.
when you wait,
E
get
to
in the
power
habit
of
of this, Chelsea. When you equally
No!
sides, when you equally to both sides, just know that it cancels out with this natural log. So when you come to write it, just say x. Is that okay?
Yeah.
Yeah, because if you natural log e to the power of x, these two they cancel each other out. If you e natural log of x, these two cancel each other out as well, leaving you with x. So when you e equally to both sides, just like x, Chelsea, in here.
Yeah.
Yeah? Go on.
Okay.
Yeah, so write it. Santa's
Okay.
not gonna do it.
Okay.
Yeah. And then yeah, so just do it like this. So it keeps it neat and tidy rather than having this ugly e natural log of x thing. Anyway, now what? Yeah. So so you would use implicit differentiation. So when you differentiate this, it would just be its exact same self, but y is a function of x. So you stick dy by dx in here. Yeah, good. And then what? Yeah, and then what? Yeah, because this looks the same as this.
Good.
Very good, very good. Okay, how about this? Well, don't celebrate too soon, Chelsea. How do you differentiate
Shut
that?
it.
X to the power of x. Give up. Cool, very good. Good. Now what?
Now I think.
Okay.
Uh,
Oh, well, wait there. How do you differentiate this?
I actually don't know.
Natural log.
ln
How do you differentiate?
y dy by dx. Wouldn't it
No,
be?
no. How do you differentiate natural log of x? How do you differentiate natural log of x,
Oh,
Chelsea?
oh.
When you differentiate natural log of x, it's 1 over x. Yeah, so it's 1 over y dy by dx. And then this thing here is like one block times another block. This block is a variable. This block is a variable. Yeah. You leave the first alone. You differentiate the second. And then what? Plus.
You leave the first alone, or you differentiate the first, leave the second alone.
Yeah. Yeah. And now what? Can you tidy this up? It looks a bit ugly. Can you tidy that up, Charles? Charles? Chelsea, you there?
Oh yeah, I'm thinking.
How do you tidy this up?
Wouldn't that just be x over x, which is just 1?
Yeah. One.
So it will be ln x.
What? What's
No,
x?
delete all this.
No. You're plusing. You're not multiplying, Chelsea. This is a plus.
Yeah.
Yeah.
1 plus ln x? Oh yeah.
One plus x is 1 plus x. 1 times x is x. And you see, you still got two blocks, Chelsea.
Okay.
Do you understand, Chelsea? Hang on, Chelsea. Hang on,
Yes.
Chelsea. You were thinking of this 1 plus natural log of x, and then you then said, oh, that becomes natural log of x, right? That's what you said, wasn't it? But it's not right.
Wait, I'm thinking.
Okay.
1
So what?
ln x.
What?
Should just be 1 ln x. ln x.
No, it won't be 1 ln x, Chelsea. It's like me asking you to simplify this. What's 1 plus a plus a? Well, Chelsea, this is like same entity. You can merge them together, right, Chelsea?
Okay, so what do I
Chelsea,
do then?
how come you're so quiet? I can barely hear you now. Are you away from the microphone?
Sorry.
What,
You're
Chelsea?
right.
Wait there, Chelsea. Chelsea, what's a block of 1 times a? What's 1 plus a? Remember, when you times, they merge together to give you a. This one here is like me saying this is an elephant, this is a giraffe. They're two different entities. You can't merge them together. Yeah, or nay? Oh, all right, hang on, Chelsea. Hang on. What? Simplify this for me. 1 plus x plus x plus 3. How do you simplify this? Oh, I'm going to add y in there as well. How do you simplify this?
2x plus 4 plus y.
Yeah, because this and single number, you can merge them together, right? Same entity. You might as well. It's like me saying one elephant plus another elephant. It becomes 2 elephants, right? And this is like your hyena. So it stays as your hyena. There's no other hyena around, right? Well, you can think of this as being like an elephant. This is your elephant. This is a giraffe. They're two different entities. You can't merge them together. So why do you say it's ln x?
What? What did I say? Did I say that?
Yeah, you said, oh, let's simplify this whole thing as being ln x.
No, I said 1 plus ln x.
Did you?
Cannot be simplified.
Oh, okay. Well, let's start again here. So going back to here, Chelsea, how would you simplify this whole thing here?
Okay, so multiply the x to the top and the whole thing will be 1.
Anyway, just put it down and write
Plus ln x.
Okay, now what? Good. Now what?
Simplify the ln x. which would be 1 plus 1 over x. Yeah?
What's over here?
1y dy dx.
No, wait there, hang on. How does this, you see, what you've done here is you're in the process of differentiating. You're not differentiating.
But
Well,
wait, why not?
why did you differentiate this block?
To make it more simpler?
No. Wait there. When you differentiate something, you've changed the whole thing. When I say simplify, it means you preserve everything.
Oh.
But then here, you've differentiated this block here to give you 1 over x, but that's not really tidying up.
Oh.
So how do you tidy this up?
Times y?
Yeah, because your job is to get dy by dx on its own, because we're trying to find dy by dx. So get dy by dx on its own. Hey, you said times y, didn't you?
Oh. Oops.
So you can think of this as like one block and another block. Yeah, you could do that. Or you can just times this by y. You can
No,
just
I like it like this, much neater.
And then this is your final answer, right?
Yes.
No.
Wrong.
Because we don't want to in terms of y.
No,
so
we don't want y.
We've got to go all the way back to here, Chelsea. Chelsea?
Oh. X to the
We've got to
power
go
of
all
x.
the way back to here.
Why are you going so long?
Yeah, and that's how you differentiate x to the power of x. You see that?
Yeah. Easy peasy.
Okay. Okay, what was the other one that you guys always get stuck on? Oh yeah, it was something like this. Y equals log, let's say log base 3 of x. So how would, in your mind, how would you picture this graph? What does log base 3 of x look like as a graph? You can't remember, so I'm just going to tell you. Is that okay?
No, I do. I do not.
Yeah. Okay, so to picture this in your mind, you've got to picture e to the power of x. Sorry, 3 to the power of x looks like this. Right, Chelsea?
Okay.
3 to the power of x looks something like this. I don't care. Looks just slightly steeper. Okay, Chelsea?
Okay.
Well, log is the inverse of 3 to the power of x. So it's really a reflection along that graph. So it's a reflection of that graph along the diagonal line. So so if you reflect it, it will look something like this. So this is your y equals log base 3 of x, because the log function is the inverse of this 3 to the power of x thing. Can you see that, Charles?
Yeah.
So when I
it's
ask
just the opposite. Oh, yeah.
reflection, yeah. So when I ask you for the log base 3, you got to think of 3 to the power of x, and then in your mind reflect along the diagonal to give you this. Right, Charles? Right.
Okay.
Yeah or no, Chelsea?
Yes. Yeah.
Okay. What's the coordinate right here, Chelsea?
Where? That is 0, comma.
0 across.
No.
It's comma
3,
0.
comma across. Or
No,
3, comma 0.
it's not 3, Chelsea.
Or no. Something, comma 0.
But wait, Chelsea, this thing here is a reflection of this point here. Can you see that? Can you see that, Chelsea? So what's this? Well, what's the coordinate right here?
0, comma 1.
0, 1. So when you reflect it, it would be
0
1,
or 1, comma 0.
Not 3. You're just guessing that this 3 goes into here, but it's actually 1. Okay, Chelsea.
3.
Okay, let's look at this graph. Y equals. Hang on, I'm just going to zoom into 100%. So you might have to adjust accordingly. So y equals let's say log base 5 of x. What does that look? Well, it looks something like this, Chelsea. What's the coordinate here?
Let me think.
So this is log base 5.
Yeah. So let me think. Wait, hold on. Let me think. But eh,
Give up?
that- I forgot what the opposite would it be. Y equals 5 to the power of x, or x to the power of 5.
Okay, let me ask you a different question. Sketch that graph. What goes on in your mind when you sketch that?
The inverse.
The inverse of what?
Not the inverse, the opposite, which is this,
Well,
but on 5.
the opposite of what's this? What's this equation?
The opposite of log 5x.
Y equals what? 5x, like this?
No. The opposite of log 5x.
No. I want to know what's the equation of this line?
5 to the power of x.
5 to the power of x. Yeah. So that log thing is really a reflection along the diagonal,
Yeah.
right?
Mhm.
Okay. You see, this point here is really a reflection of this green point here. So when I asked you for the coordinate here, you got to somehow in your mind picture this point here,
1.
Chelsea. Yeah, it's 1. So this
So the
this point
opposite
here,
1 comma 0.
well, not the opposite, but it's a reflection along the diagonal. So yeah,
The reflected part.
yeah, it's actually 1,0. Can you see that, Chelsea?
Yes.
Anyway,
That's what I
how do you
said.
okay. So how do you differentiate it? Find dy by dx. You see, this thing here, y equals natural log of x, is actually easy to differentiate in comparison to base 5. So what do? You wait for Christmas or summon the Almighty?
Exponentiate by 5.
With base 5. Yeah,
Base
but Chelsea, remember that thing that I told you, Chelsea, they cancel each other out? So don't
Yes,
bother
I'm
wasting.
going to it.
Just write x, because you know the
You are
5.
so complicated.
I think you're complicated.
And then
Yeah.
y, and then 5.
So what are you doing to both sides, Chelsea?
I'm logging them now.
So why didn't you log the right-hand side?
I did.
You didn't? Because this is like one... A liar, man.
Here, I'll write it properly.
Natural log of x. Cool. And now what?
Okay. Now. 1, 2.
Is this a constant or is it a variable?
That is a constant.
Yeah, so in your mind, just think of this as being like a number, like no, I don't know, 0.27 or whatever.
Okay,
It's
so
just
once you differentiate.
Right, anyway, what do? No. Chelsea, how do you differentiate x natural log of 5? So what's dy by dx here?
I don't know.
Okay, Chelsea, all right, on the right hand side, how do you differentiate this? Y equals x to the x times 5. How do you find dy by dx?
You do the multiplication, the quotient rule.
No, you mean the product rule.
The product rule, yes.
You got one. No, you see, the product rule is when you have a variable times another variable. This is a constant.
Oh, differentiated.
Yeah, so how do you
So
differentiate?
it would just be 1.
No, how do you differentiate x times 5?
1.
No. Oh, okay? You want to do that? Well, wait, you're not even using the product rule because this is a constant, Chelsea. So don't bother. Oh, all right, Chelsea. Can I forget about this and ask you a different question?
Oh my gosh.
How,
Okay.
how do you differentiate 5x?
It would just be
What? What's dy by dx? Chelsea? No.
it would just be 5. Just be 5.
Yes, that's 5.
Yeah.
So this is exactly the same as this. When you differentiate it, it's just the number 5. That 5 is a
Oh,
constant. See?
it caught me off guard when it was the opposite.
Well, Chelsea, this thing here is just a constant. It's just a number. So when you differentiate this, it's just natural log of 5. It's just a number. Who cares what that number is? Just imagine it to be, I don't know, 2.27 whatever. It's just a number. Who cares what that number is? It's just a number. Right, Chelsea?
Uh-huh.
So going back to here, Chelsea, you've got one block times another block. So when you differentiate this, it should be natural log of 5 because this is just a number. And then
Okay.
you've got to times by the derivative of, you've got to stick dy by dx after that because y is a function of x. So my point here, Chelsea, is that when you differentiate this, right, Chelsea, it just becomes the natural log of 5 as one block. But because y is a function of x, I need to stick dy by dx in there. Yay or nay?
Yay. No. Yes. Yeah.
Yeah, because it's like me asking you to differentiate. How do you differentiate this, Chelsea? X3. When you differentiate it, it just becomes 3,
Yes.
right? So when you
No.
differentiate this, yeah,
If you
what?
differentiate it, wouldn't it be 3x2?
Oh, no, that's not to the power of 3. I'm saying.
Oh, yes.
Right. So it's just like this thing here. This is your variable. This is your constant. So instead of writing
So it's
3,
ln5 dy by dx.
yeah.
Oh, okay.
Okay. So it's not really a product rule. You don't use a product rule just because this is a constant. Okay, Chelsea?
Okay.
Anyway, what now? Differentiate the right hand side. Differentiate the right hand side, Chelsea.
Give me a second.
No yawning in maths. How do you differentiate this? Yeah. And concentrate on dy by dx. You're trying to get dy by dx on its own. What do you do to both sides?
Divide ln5.
Yeah. So what does that then give you? When you
Oh, it goes to the bottom, doesn't it?
yeah, divided by a number, when you divide a fraction, it gets multiplied to the bottom.
Yeah, sorry.
So what goes in here? Yeah, and that's your final answer. That's how you differentiate log base 5 of x. You see that, Chelsea? Okay, we call it a day here. How do I stop this recording thing? What do I do?
You go back to when you started recording.
Oh,
Or if you end the call, it will stop automatically.
Well, automatically. So I can just press the red button, can I?
Well, if you just hang up, then it will stop the recording.
Are you sure? I'm not gonna lose it. All right, I'm just gonna put it.